Okay, so now this is the very last talk from Thomas Feliciani and joint work with Chiara Franzoni, both from the Polytechnic di Milano. And it's called Overcoming Conservatism in Funding Decisions, the Selection Procedure as a Promising Area of Interventions. So Thomas, please, the floor is yours.
Thank you. And as the last speaker, I feel the pressure to be concise, but at the same time, an extremely strong urge to connect everything I say to what has been said by you over the past 3 days. So you know what I'm navigating here. Now, many of you have said how important it is that we reflect on how funding is allocated. And well, I'm going to preach to the choir because it's exactly what we are doing in Milan. And I will focus specifically on how we allocate funding to enable highly innovative research. So how we reward novelty in grant applications. And so you can listen to my talk wearing the shoes of a funder who's trying to figure out how to select and enable highly innovative science, or you can take on the perspective of a prospect applicant who's trying to gauge whether to submit their highly innovative, daring research idea and where to submit it. My starting point is the observation made by some that the odds are stacked against highly innovative research. And there are a few reasons for this. I list here some prominent ones that I'm going to be talking about. The first one is the claim that reviewers are conservative. So all other things being equal, reviewers tend to give more negative grades to highly innovative research, and they tend to be more positive toward research that uses more traditional approaches. And not only is individual reviewers being conservative, review panels are conservative also. And this also has its reasons. One of them is simply how wisdom of crowd works. So wisdom of crowd really works when the biases and errors of different raters cancel each other out. But if there is a consistent conservative bias in the panel, well, then the wisdom of crowd is going to be just as equally biased. And another reason why panels are conservative is the kind of social influence dynamics that are at play during panel discussions. And there are several examples of this, and I don't have time, so I'm just going to mention one. And that's the fact that, as some authors claim, panels during panel discussion are very fast to accept, so to revise downwards their opinion of a proposal where new evidence comes up about the weaknesses of a certain proposal. But they're not equally easy to pick up new information about the strength of a proposal. So there is a systematic bias towards, so during the panel discussion, there is a systematic bias that reinforces negative opinions about the proposal. Now, also because of these two facts, applicants might anticipate trouble when they decide whether to submit their innovative funding proposals. So they might self-censor. Yeah, over the past days, Pence has prompted me to think a bit more about the distinction between what's descriptive and what's normative. And I thought, okay, so what I have on this slide is definitely descriptive. But I need to shift gears and start being normative. And that's because, again, I'm taking the perspective of funders, and funders think this is a problem. So they, if you look at their mandate and what they advertise in the funding calls, they really try to attract innovative research. They really seek to fund innovative research. Yeah, so they want to fix conservatism. And they have a few tools in their arsenals to do that. And these are 3 tools that I'm going to be talking about. The first one is to run a novelty-dedicated funding calls. So this is about setting up a stream of funding dedicated to funding highly innovative or disruptive research. And funders who set up such funding streams also provide the reviewers with instructions as to how to reward in novelty instead of punishing novelty. So these kind of panels, as in the mind of funders, serve two purposes. One is to create an incentive for applicants to actually submit their best ideas, and on the other hand, to basically minimize these conservative tendencies of reviewers and review panels. A second solution is to do something about how the opinions of different reviewers are put together. Now, as I said, review panels usually don't compensate for or don't even minimize the conservative tendencies of their individual reviewers. So a possible solution there is to replace these panel discussions with some method of aggregating reviewer opinions that are more resistant, more robust to conservatism. And I'm going to be talking about a bit more about what kind of algorithmic aggregation approaches there are. And the last solution that is being explored are funding lotteries. So the idea of randomizing, at least partially, the selection procedure. And the idea here again is to basically minimize the amount of conservatism that creeps into the panel discussion. All right. So we have these three tools to curb conservatism. And my research question, my overarching research question is basically to gauge their effectiveness at basically allowing review panels to select select on novelty. And to evaluate this, we can leverage a pretty unique data set. It's pretty unique both for size and for granularity. So we have access to all funding applications that were submitted to Novo Nordisk Foundation over the course of 10 years. And Novo Nordisk is a major private funder. By some metrics, the largest in the world. And yeah, so our original data set for this time frame included shy of 14,000 funding applications. We had to remove some of these for various reasons. Some we had to remove because the funding calls were too small, like we received only one application. Some other calls we had to remove because we didn't have access to some of the metadata that we needed. So we ended up with shy of 13,000 applications submitted to 257 funding calls. So I'm now going to examine each of these possible solutions to conservatism in sequence. So starting with the idea of novelty-dedicated funding calls. Now, in our data set, 13 of these funding calls were novelty-dedicated calls. They're called Synergy by Novo Nordisk. And I pasted here a description that's publicized on the website of this funding call. And I'm just going to read some keywords here. So, project should be based on a novel research idea. Now, in different years, they replace novel with the word creative or untested research idea. Then it goes on. Interdisciplinary challenges, novel interdisciplinary research, high-risk, high-gain element, and potential for disruptive science and development of entirely new research areas. So a very broad definition of what is novel, but at least it gives us an idea of what it is that funders want to fund when they say that they want to fund novel research. And of course, Novo Nordisk for Synergy Grant also provides reviewers with consistent instructions. So it instructs reviewers to basically seek or to check which of the applications have these characteristics. All right. So based on that description, I think I can identify at least some of the relevant dimensions of novelty. So starting with the concept of recency. So looking at the description, it is clear to me that when funders say that they want to fund novel research, what they mean is that they want to fund research that promises to deliver on the following: a project that introduces new research ideas, new methods, or that introduces new research areas. A different dimension, I think, is that of recombinatorial creativity. That's how we call it. So this is an idea grounded in social psychology that says that when we do something novel, when we do something creative, it doesn't come out of the blue, but it emerges from us recombining in some novel ways something that we already knew that was already there. So this dimension sort of captured that idea of recombining something that's already there. And now I could just have a different talk on how to measure these concepts. And some of these measurements to capture these concepts also have some overlap with the idea of interdisciplinarity. So yeah, I would like to see if Wolfgang agrees with my assessment here that the literature on measurements on measures of novelty is actually quite chaotic. There is a cacophony of measurements. There's a cacophony of indicators. Different indicators have different variants, and yeah, it's really clear that some systematizing is needed in the literature. So we're making do with what is there already. And what is there are a few indicators that you can map to these two dimensions of novelty. And but in the interest of time, I will focus on the ones that are not grayed out. So novelty is recency. We measure looking at mesh terms. For those of you who don't know, mesh is an acronym that stands for medical subject heading. So these are like keywords. It's actually a curated list of keywords, and a new keyword is added to this list when it's discussed in the literature. So I can mark a funding proposal as novel if I can assign to it a mesh term, a mesh keyword that is not already indexed. All right. Now, for recombinatory creativity, some talks on Monday, Arno especially, talked about this idea of word embeddings and how we can use them to capture the similarity between pieces of text. So there is this index by Shibayama, who basically captured this semantic similarity between the titles of the cited references, right? So the more dissimilar the cited references are, the more novel this recombination of ideas is. All right. So our plan here is to use different measures to calculate, to test for to also control for the robustness of this of the operationalization of these concepts. Okay, I think before I show you the first result about the effectiveness of novelty-dedicated calls, I want to show you this plot. And I need to start with explaining what you're looking at. So we have two panels dedicated to the two different dimensions of novelty. And on the x-axis, I'm plotting, well, the average novelty, in this case of all submitted applications. So in a way, this is a measure of how effective a type of funding call is at attracting novel applications. And when Chiara and I looked at these results, we were quite taken aback. So if we look at novelties of recombinatory creativity, we can see that novelty-dedicated panels really do score higher on novelty, meaning that they attract proposals with higher average novelty. But if you look at novelty's recency, it's the other way around. So it seems as if novelty-dedicated calls attract submissions with less novel ideas. Yeah. So with this in mind, I now show you the distribution of novelty across some applications that were granted, that were awarded. And we kind of have the same picture. So again, we have that synergy grants tend to be higher in novelty than all other types of grants. And again, and this time we don't see quite a difference between synergy grants and the other types of grants. There might be an improvement there, but it's a small improvement in novelty's recency. So yeah, this is our first result about the effectiveness of novelty-dedicated calls. Are they effective? Yeah, when it comes to novelty's recombinatory creativity, But then again, this seems to be very much driven by the fact that these novelty dedicated calls attract more novel submissions in the first place. So it's not really, it doesn't seem to be really much about the selection, but this attractiveness for applicants who are thinking to submit novel proposals. Now shifting gears, and I move on to the other kind of interventions that can be done. I have here a slide on aggregation methods. And again, recall the one of the ways in which panels make conservative decisions is through panel discussions. So the idea is, can we replace these panel discussions with some other method for aggregating individual reviews that is a bit more robust to conservatism? And there are some really trivial ways to do this. So, for example, we can stipulate that the collective panel opinion about the proposal is the average of the opinions of its individual reviewers. So that's aggregation by mean. Yeah. And there is, of course, a concern that the opinions that are most negative in the peer review panel are those by particularly conservative reviewers. Now, if that's the case, those conservative reviewers will still be able to skew the mean. So that's why we're also testing the effectiveness of aggregating by median, which is obviously robust to outliers. And what I call here the best grade is an extreme version of such a solution. So aggregating by best grade, it means stipulating that the opinion that a panel forms about a given application is the most positive opinion expressed by the panel. And so this is a pretty extreme intervention, and no funding agency is implementing such a system. But they're implementing something very similar, golden tickets. Think about it. What a golden ticket is this option given to reviewers. So if a reviewer really likes a particular application, they can spend their golden ticket on that application. And this basically automatically ensure that that application they like is chosen, is funded. So golden ticket is a realistic version of what I call the best grade. All right, so these are the aggregation rules. I'm gonna also show you immediately, tell you immediately about the third tool in the arsenal, funding lotteries. Now, there are different ways of implementing a funding lottery. So, for example, the Swiss National Science Foundation uses tie-breaking lotteries. So they really use randomization when some reviewers, some review panels cannot tell which of 2 or 3 or 4 applications are the best. So in this kind of use of lotteries, randomness really plays a limited role. It's not always used, and when it's used, it's used to break ties among very few proposals. And here I wanted to test the effectiveness of lotteries. So I implemented a way more extreme form of lottery, one adopted by some funders, as you see on the slide. And this works as follows. So the panel is instructed with drawing a fundable line, all right? So they put applications into boxes, those that are fundable, those that meet some quality minimum, and those that are not fundable. And yeah, and the fundable box, that's the lottery pool. The winners are drawn at random. All right. So I already said a bit about why lotteries would curb conservatism, and I'm late, so I'm gonna skip that. Yeah, so how do we test the effectiveness of various aggregation methods and of lotteries? Well, by simulating counterfactuals. That means that for every real world funding cost we have in a data set, we keep everything constant, we keep everything the same. So the same applications were submitted, the same grades were issued, we keep the funding rate constant. The only thing we changed is how the decision is made, right? So how reviews are aggregated, if we are testing for aggregation rules, or how winners are chosen, if we are testing lotteries. So these are what I call counterfactuals. So they're simulated scenarios. And yeah, so here, okay, so again, before I show you the result, here is a preliminary plot. So here I'm plotting a measure of the difference that these various mechanisms make in the panel decisions. So on the x-axis, you have a proportion. That's a proportion of proposals that would have been funded in my counterfactual scenario that were actually rejected by the real panel. So if we have a proportion of 1, that means that my counterfactual scenario has chosen a completely different set of proposals to be funded than was actually chosen. And you can see from this plot that most aggregation rules actually don't affect panel decisions all that much. Like if you aggregate by mean, for example, the difference in which proposals get funded is rather minimal. It only involves like 20% of proposals. But if you run with a lottery, then about 60% of funding decisions would have been different. All right, so this already created me the expectation that aggregation by best grade and funding lotteries will have bigger impact on the novelty of fund applications. So here are the results. So again, as before, we have novelty on the x-axis, and now I put in basically all the scenarios I have. So we have the baseline. So these are the real calls. I repeat it here just for reference, the novelty of the novelty dedicated calls. And on the last rows, we have, well, the different aggregation rules I'm trying out and lotteries as last. And at a glance, what I see here is that there is very little difference between our baseline and the various interventions. And if anything, it seems that novelty-dedicated panels are already doing quite well. Now, if we zoom into these differences, we actually find some significant effects. So, for example, we find that lotteries and aggregation by best grade significantly improve the novelty of funded proposals relative to the baseline, but this effect is really small. So to wrap this up, so there seem to be really marginal improvements to be gained from using these alternative selection procedures, at least when it comes to novelty. Aggregation by best grade and funding lotteries seem to be the most promising, but most of all, I would say the novelty dedicated funding calls that Novo Nordisk is already running seem already to be quite effective. Now, the limitations, which also are my next step of research. Now, what I haven't told you yet, or I haven't stressed yet, is that the selection procedure also has an effect on whether applicants decide to submit their proposals. And so if an applicant knew that they were playing with a lottery system, perhaps they would have tried to submit something more daring, right? And that's also something we can explore with counterfactuals, and that's on my to-do list. And another thing I haven't explored in this slide yet is the fact that these different tools can be combined. So there are funders who are running a lottery with the equivalent of golden tickets and using fancy aggregation methods. And perhaps there are advantages to be gained from combining these solutions. So yeah, that's it for my talk.
Thank you very much, Thomas. Super interesting. Cassidy, please. We have 10 minutes or so for questions.
Thank you. So interesting. I love this. So I have many questions, but I'll try to make few and keep them short. One of them comes back to the normative claim again, right? Mm-hmm. That is novelty good? Mm-hmm. And particularly is this operationalization of novelty good, that is with the recency and the recombinatorial. So most of what we have seen before is that things like novelty or interdisciplinarity, as it's often operationalized, is nonlinear, right? It doesn't get better when we associate it with other evaluative criteria that are proxies for quality. There's a point of diminishing return.
Yeah.
And I think a lot of this model assumes that there's not, that there's a linearity in this, and the more novelty you get through recency or recombination is better. And I say, we all know logically that doesn't make sense, right? Some things should not be combined, right? It doesn't have a good outcome.
Absolutely.
And we've seen that, I mean, we've shown that in interdisciplinarity studies as well. So I want to go back to your two slides of results, because in some ways I think they point to it. We'll go to the first one and then stop at this one again. So back to the very first thing, because what I think is actually interesting here is the delta on this, because what I see there is that you have actually an advantage here in recombinatorial creativity beyond what is submitted and what is granted, which does suggest some quality association with recombination that you're not necessarily seeing in recency. So I think measuring that delta calls into question sort of those underlying normative assumptions. And we see that even more in your last set of results. So if you go to 3, what I actually read is that recency isn't good, isn't high quality, given that randomness increases the probability of recency in some effect. That could show me that recency is actually a bad effect that we're seeing here. So I want you to sort of speak to that, like, what are you seeing in here? There's an assumption that recency and recombinatorial creativity are good. What I see in your results are recombinatorial creativity actually may be better research, recency may be garbage.
So I'm gonna pick up on the last thing you said, that so the okay, so actually let me try to respond this with the general statement. You're absolutely right. We don't know whether we really want more novelty. Novelty is not necessarily good. Actually, it's very reasonable to think that beyond a certain threshold, novelty is garbage. Still, the question remains: how do our selection procedures affect the distribution novelty in funded science? That's still a valid question, important question to answer. And yeah, the one way to look at this result is the descriptive stance and not a normative stance. And still, funders want a normative answer about this also.
Thank you very much. But I think that the method you applied can be applied about evaluation of any demands, because I think the point which is the most important is that take any program, not about novelty, because of course in any program, even in philosophy, history of science, you take about 15% of them, and you expect that if they take them, it's because within the demands, they think they are the best. So whatever that means, we don't know, but we don't care. So the point that I think, which is very, very good at the empirical level, that if you apply that to those programs, the point which is the most important is the robustness. Is, for example, of course, with the lottery, it's normal that you will get a much larger range of. And I mentioned that because the scientists are very conservative, and I will give you a story that it's a thing that we did. It's a report that we did for the CRHR, which is the Canadian Institute for Advanced Research. They wanted to scrap the panels because it costs millions of dollars. You bring people around the table, you pay the hotel, you pay the plane. It costs millions of dollars. So they asked us, they say, but people have to send before their own ranking. So everyone is somewhere, they rank. The head get the average rank. Then they meet. Then they discuss, well, you know what, it's good. Everyone agrees on the first, so it's good. Okay, so we just compare the ranking after the meetings and the ranking before that. And in short, it's essentially the same, except for a few variations, which in fact, the scientists said, oh, the government should not do that because it's good to meet, we change the thing. But I said, yes, but even the change can be, in fact, a bad thing, because if they change, it's maybe because there's one guy on the panel like me, that is garbage, and everyone was telling us, okay, you're right, we put it down. So it's not ethical. So we said should not go back on this. We should keep it. So the scientists went to the government, the minister, and the minister forced it's a secret. forces the CIHR to go back to the meeting. So I said, but it's irrational. So the data showed that, in fact, we save millions of dollars that could go in the research demands. But so use that to show the variation in the randomness, in fact, I think.
Absolutely. Yeah. Yeah, that's a great idea, and I was trying to hint at that here. Obviously, I cannot really explore it fully in such a short presentation. But you're right, there's also the issue that peer review panels sometimes, as you hint, to rationalize so that they reason backward from, so that they know that they want to fund some research, and they try to justify that ranking. And this happens perhaps, so very likely at the reviewer level, possibly at the review panel level. Yeah, so that would be an additional reason to explore alternative methods that basically prevent this possibility.
Thank you. Thank you for the interesting research. And I think I don't know much about I'm fascinated by the whole lottery approach, but I can only speak now. I'm just going to draw upon some personal experience. I was delighted to sit not on a panel, but to serve as a reviewer for a project, a U-level project. And in fact, I thought the project was really novel and I wanted it to do well, but what it missed was executability. So I think, you know what I mean? You can have people that have these really novel ideas, but the details just don't add up to how well you're going to execute this. So I think we have to be conservative when we execute and show a very, very clear plan, a data plan, everything, not just novelty. So maybe it would be nice to introduce another variable into this.
I think this comment really helps me to put a bit better into focus what Cassidy has said. So novelty alone, so it's not just novelty. So if novelty means sacrificing quality, then obviously we don't want novelty. Now in this counterfactual simulated, obviously there is a quality check before the selection is made. So the selection is made on quality. And then we look at downstream what happens to the novelty distribution downstream of that decision on quality. Still, quality is not the only important dimension. Perhaps it's not even the most important dimension. Probably it's not the most important dimension. Now, I have different. I have some other pieces of work where I explore different outcome measures of these selection procedures. And in those pieces of work, quality is one of the outcomes to look at. And the results are pretty similar. So if you randomize a lottery decision, for example, using a lottery, then you see that selection procedure is impacting the distribution of quality a lot. But for low randomness procedures like aggregating by averaging, then the impact is minimal. So it really seems. This suggests, obviously, I would like to test this. This suggests that perhaps there is an inverse relationship between quality and novelty.
Great. I think that on these questions, we can actually thank the organizers.